In number 1, we want to find the volume of the solid of revolution formed by rotating the region bounded by y equal minus x squared plus 1. That's this curve over here, which is a parabola facing down. X equals 0, that's here, x equals 1, and y equals 0. About the y-axis. So we want to rotate it this way about the y-axis. So usually when we rotate about the y-axis, and if we're doing a dx integral, then we're going to use, very often we use the shell method. All right, let's look at what we mean by that. Well, here, if we draw this slice of the region, which is this rectangle over here, and picture rotating this rectangle about the y-axis. So what we would get is a thickened cylinder. Okay, so let me just draw a picture of a cylinder. And here's the original rectangle that was rotated about the y-axis. Okay, so we get this little, we call it a shell, or a cylinder that has some thickness to it. Now let's remember what the area of a cylinder is. So the outside of the cylinder has area 2 pi r h. 2 pi r for the circumference and h for the height. All right, and now if we are interested in the volume of the shell, we're going to multiply by this thickness that we call dx. Now the shell method, the formula for obtaining the volume of these solids of revolution using the shell method is based on this formula 2 pi r h times dx. So let's look at it. All right. We have the volume is equal to the integral, and this is going to be the general formula from a to b of 2 pi. Now instead of the radius we have x. I'll explain that in a minute. Instead of the height we have f of x dx. So this is like our 2 pi. This is the r, and this is the h. Okay, so if we look at this again, this rectangle that we're spinning about the y-axis, when we spin it about the y-axis, the radius is from here to here, from here to some x value, corresponding to, and the height is correspondingly f of x. So here we have the radius x, height f of x. So here's the radius x, and here's the height f of x. F of x is the height underneath this curve, and dx is the thickness. So here's the formula again based on 2 pi r h. And x varies depending on where we are along underneath this curve. Okay? So x is going to vary from a to b, in our case from 0 to 1. Every time x changes, so does the position of this rectangle. All right, so let's write our formula in our case. In our case, I'm going to just pull out that 2 pi. In our case, we're integrating between 0 and 1 x, and f of x is minus x squared plus 1 dx. All right, so let's just simplify that a little bit. Multiplying through by x, we have minus x cubed plus x dx. And now we'll integrate with the power rule, minus x to the 4th over 4 plus x squared over 2. And let's put in our limits. Okay, first substitute in 1, and we have minus 1/4 plus 1/2. And when we substitute in 0, we get 0. So this is 2 pi times 1/2, or just pi. And number 2, we want to find the volume of the solid of revolution formed by rotating the region bounded by y equals square root of x, that's here, and y equals x squared, about the y-axis. So we're rotating this way. So when we rotate this piece around, we're going to get a cylinder. One way of remembering if you're going to use cylindrical shells or if you're going to use the disk method is if the rectangle that you're rotating is parallel to the axis of rotation. So this rectangle is parallel to the y-axis. That means we're doing shell. All right. If we rotated about the x-axis, then the rectangle would be perpendicular to the x-axis, and we would be doing the disk method. All right, so when the rectangle is parallel to the axis of rotation, then the method is shell. So we're doing the shell method here. Okay, so we're going to use this formula, and it's based on 2 pi RH, the volume or the area of a cylinder. So here we have 2 pi. The radius is x, and the height is, in this case, the difference between the square root of x and x squared. This rectangle doesn't sit on the x-axis. The top of it is at square root of x, and the bottom is at x squared. So the height of the rectangle, so that would correspond to the h in the cylinder formula, is square root of x minus x squared. All right. So let's and here our a is going to be 0 and our b is 1. All right, so let's simplify this a little bit. I'll take out the 2 pi, 0, 1, multiply through. All right, x times square root of x. Square root of x, that's x to the 1/2. So that would be, this times this is x to the 3/2. Minus x times x squared dx. All right, so there we have 2 pi x to the 5/2 times 2/5 minus x to the 4/4 between 0 and 1. So that, substituting in 1, we have 2/5 minus 1/4. And substitute in 0, and we have 0. So we'll just combine those fractions. Okay, get a common denominator. Okay, multiply top and bottom by 4, and here multiply top and bottom by 5. And we have 2 pi times 3/20, or 3 pi over 10.